Okay, so let us talk, oh, wrong one. Let us talk about a little bit of a review of the last lesson. So in the last lesson, we were introduced to circle geometry. And circle geometry has a couple of important words that we need to know. I want to ask you in the chat to tell me what is the word for that particular line. Put your answer in the chat. In the world of circle geometry, what is the word for that? Oh, you guys are on fire. It is the diameter. And what if I choose these 2 points? I want to know what is the name of the green straight line. Okay, so the green straight line is indeed going to be a chord. So the green one is a chord, and the yellow one was a diameter. What about the pink line? What is that called in the world of circle geometry? So I can see lots of you in the chat are saying it's a tangent, which is awesome. What is the name of the blue line that I've just drawn, or at least tried to draw? Okay, so that is the radius. Now, there were a couple of other words we touched on, but those are the major ones. And then something else we spoke about in the last lesson was if we have an arc. Now, an arc would just be going between 2 points along the circumference of the circle, and we subtend an angle at the center. That's what we call subtending an angle at the center. And then if we go up here, that's using an arc to subtend an angle at the circumference. Now, we sometimes say that an arc will subtend the angle, but it's also possible to say that a chord will subtend. Let's call this A and B. So you can say that the arc AB subtends an angle at the center and subtends an angle at the circumference, but some textbooks will say that the chord AB subtends an angle at the center and the circumference. You're allowed to use either of them. So I just wanted to point that out because in the last lesson, I focused more on the arc, but you sometimes see textbooks say chord AB, and both of those can be used. Now, what I want to ask is, what is the relationship between the, let's say, the pink angle and the yellow angle? I'd love someone to come online and just tell me a little bit about the relationship. Let's go to you.
Hi, sir.
Hey.
How are you?
I'm very good. And you,
I'm good. I'm also good, sir. Sorry. Isn't the relationship that the angle at the center or the angle subtended by the arc at the center of a circle is double the size of an angle subtended by the same arc on the circumference of the circle?
Yo. So good. So good. Okay. So this is a very important idea that the angle at the center is twice the size of the angle at the circumference. The other thing we learned about in the last lesson is that by dragging this point around, we can sometimes get different shapes. So it is possible to get different shapes of this. Let me actually grab the, where's my visuals? Here we go. So if I go to my live drawing here, let me show it to you here. And I think this is what we found hard is, actually, I haven't shown you this yet, but I'm going to show it to you. If we look at this, the shape looks like an arrowhead. What's going to be a little bit new today is instead of just having the arrowhead, if I drag this around, can you see that it's possible to have a different shape? it doesn't look, it's still, there's still the arc CD, which has an angle at the center, and then the arc CD has an angle at the circumference, but it looks a little bit like, I don't know, what would you say? If it goes here, it looks a bit different. So give me a thumbs up if you can understand the different looking shape, even though it's the same theorem, that it looks a bit different. Because we're going to practice some questions now where we don't just have the arrowhead shape, we'll have this shape over here. It looks a bit like a sweet wrapper, or like a, I don't know, we'll give it a funky name. But now, all I'm doing is I'm comparing, this is what the shape normally looks like, angle at the center, twice the angle at the circumference. But it can also look like this, where the, almost like it's the angle at the circumference is bending over to the side. Now, in order to get this, I was moving the point around the circle. Now, do you think that these two shapes are the only ones? Or do you think maybe there's a third shape that I need to show you? And how would I find that third shape? Maybe someone can come online and tell me what to do. So I've showed you the arrowhead. I've showed you the leaning to the side. But now what other shape might I be able to make with this theorem? Okay, you are on the ball today. You must have had your vitamins. Okay, what do you think?
So I can't explain exactly the shape, right? But
Yep.
It's like a kite. I can't explain. It's like kite-ish. It's like, it looks like a kite, right? But
Yeah.
you see the CD,
Yeah.
it's not there. I can't even take a picture and show you. So the CD is not, it's on top.
What you said. I like what you said. You've said something very good. Let's just take it. Instead of the CD being here, it's almost, said, what if we could have the CD be going along the top? Another way of saying it maybe is to say, can you see this point that I can drag? Look at what happens if I keep dragging it and I go like this. Oh, magical things are happening here. So what happened was, instead of focusing on what we call the minor arc, we're now talking about the major arc. So we'll do an action replay. Let's go back to the beginning. So that was what I showed you in the last lesson. Now you can have the falling over sideways shape. And then if that point, if the angle at the circumference goes the whole way around, it almost like it flipped, the flipped over shape. And what you see there is the angle at the circumference is this really big one. And then the angle at the, the angle at the center is this one. The angle at the circumference is here. And what I noticed, what makes me very happy, is that the angle at the center is 260. What's half of 260? It's just 130. Now that is a bit of a tricky idea, so we need to practice it. But I just want to see, my question is this, give me a thumbs up if you understand why there's 3 different shapes for this theorem. Thumbs up if you understand why there's 3. Thumbs down if you're like, this is all Greek to me. And I'll go through it one more time. So that's the arrowhead. Okay, that's the arrowhead where the angle at the circumference is, and then the angle at the center is like acute. Okay, I can see there's definitely mixed feelings, so don't worry. We're gonna come and practice this. If the angle at the, if it's like this, it's like falling over, and if it's flipped the whole way around, okay, don't worry, guys. I can see your votes are coming through loud and clear. Let's practice something like this where we see how it works in an actual question. I just wanted to set you up, but I know that it will make more sense after we do a couple of questions. So first question for the day. I want you to find me the value of angle X. Ask yourself, which shape does this remind me of? And then ask yourself, what's the theorem? And then give me an answer in the chat. Is it A, B, C, or D? All right, so you guys are rocking it live. This is 84 degrees because you can see that the arc is down here, and then it makes this angle over here, and that's the bigger one, and that's the one at the circumference. Okay. I like what I'm seeing. I see no problems. So let's try another one where I show you. Let's go to, where did I go? Give me a second here. On F, that's the right one. Okay, let's go to these two questions. I want you to try and find me what angle X is in question 1.1. And then I want you to also try and find me what the answer is in 1.2 for X. And for 1.2, if you're feeling like you're winning at life, maybe you can come on and explain to me your thinking. I'm not interested if you get it wrong or right. I just want to know your thinking that you use to navigate the journey. So I think most people have found that X is 50 in the first one. So I agree with you, X is 50. Now, 1.2, that looks a bit more exciting. It looks like I have to think back to the beginning of the lesson. Yeah, Faith, let's go to you. What do you think?
I think 1.2 X is equal to, oh, I thought X is, oh, sorry, sir.
No, it's fine, but give me O. What would you get for this? We'll call it O1 because it looks to me like this is called O1. Can you give me what O1 is?
O1 is 240.
Okay, how did you know it was 240? Yeah.
Because it's a major arc.
Okay, yeah. And then also, isn't this an angle in a revolution? Like the whole way around always has to be 360.
360, yes, sir.
Yeah, so 360 minus 120 is 240. Okay, now here's the tricky bit. How do I connect? What do I connect to X? Which angle is in relationship here? Oh, I lost you there, Faith. So what I was thinking is instead of focusing on AB, I'm going to focus on I'm going to focus on this long arc here. And I'm going to ask myself, what is the angle at the center for that arc? And what is the angle at the circumference? So notice the relationship. This is the one where I'll leave it like that. The 120 and the X are not the ones in relationship. Yeah. Umta, what do you think the answer is?
Hi, sir. So isn't the answer going to be 120?
Okay, it is going to be 120. Can you tell me how you did that? What did you connect to X to figure out 120?
Because the 240 is at the center, right? And it's the center point, of which the X is half of the center point, right? It's like the thing at the circumference.
Perfect. Yeah, it's exactly it. So you recognize that it's not the one it's right next to. It's actually related to the one, the O1 and the X are the one that are in relationship. Now, I know this is tricky. So I'm super impressed. And I just want you to give yourself time. It will become easier with time. But thank you, Umta. That was spot on. Let's do two more like this. Just to keep practicing, I'll leave these up on the board. But for the rest, okay, I can't quite fit them on the board, but I'll leave them up if I shrink them a bit. See if you can do 2.1 and 2.2. And in 2.1 and 2.2, you need to find for me X and Y. Oh, let me do that. Find for me X in 2.1 and then find me X and find me Y in 2.2. So pop your answers in the chat when you, or actually, you know what? Someone can come online and tell me how to do 2.1 when you feel ready, but only when you feel ready. Who else is willing to share their thinking for X? Don't worry, Sylvia, that's completely fine. We're on a journey here. Come on, I know somebody wants to help me out here on 2.1. What do you think the answer is? Pop your hand up and we can have a quick chat. Chuma, what about you? What do you think? You want to share your knowledge? Sipokazi? Okay, I see a couple of people
Hi,
up
sir.
about. Hey, Sipo, how's it going?
So it's okay, sir. How is it going your side?
It's very good, very good. I'm enjoying being with you guys.
Oh.
Tell me how did you get X?
So basically, as you've said that as long as the arc is still there, which is that point of O,
Yeah.
basically that X is going to be 120.
Yep, exactly that. So the important bit is knowing this is like the second shape I showed you. And so the 60 is the one at the circumference. It's the smaller, the center one will be 120 degrees. Perfect. Yes. Okay, let's try and do 2.2. I like it. I like it. Hearties, let's go to you.
Hello, sir.
Hey, give me your thinking for 2.2. Which one did you do first?
I got O first.
Okay. What did you get for O2?
So I basically took 360 minus minus 150.
Okay.
Then I got 210.
210. I agree with you because that adds up to 360. So
Yes,
you've got that one. And then what did you do?
Then I divided 210 by 2.
Okay.
Which gave me 15.
Okay. So you are going to get Y first, and you got Y is 105.
Yes, sir.
Okay. Brilliant. I recognize that shape is like the third shape. What about X? What did you get for X?
I divided 150 by 2, which gave me 75.
Yep. And so you're focusing on the sort of arrowhead part over here to get the X.
Yes, sir.
And then you've used both of the different shapes. That is perfect. Thank you, Hearties. Thank you so much.
Thank you, sir.
So everyone, can we have another little check-in? Thumbs up if you feel like you're following what's going on. Thumbs down if you feel a bit like there are too many circles and lines in my life. How did we get Y? So to get Y, we took the 210 and we divided that by 2 to get 105. Okay, so you can see this green one over here. This is the angle at the center. Excuse my, it's getting a bit messy, isn't it? So this is the angle at the center. And I'm using this arc over here to help me get that O2. And then once I get that, the angle at the circumference is this one down here. So these two are in relationship. And that was 210. Half of that is 105. Okay, don't worry. The more you practice, the better we get. So let's do another one, because by the end of this, you're going to be like, piece of cake, this theorem. So here is your question. Find angle ADC is 44 degrees. What is the size of angle Y? That is the question for everyone. So I'll leave the examples on the screen so you can see them. You tell me, is it A, B, C, or D? Have a look at that. See what you can do. So read the question carefully here. So the question says, what is the size of angle Y? Now, ADC is 44. So I know that this one, ADC, is 44. But what is the question asking us? Okay, let's go to Umta. Umta, what did you think about when you did this one?
Sir, I think I took D first, the 44,
Yeah.
and then I times 2 with 2 to get X.
So you got 22. No, sorry, you got
Sorry?
88. Sorry,
88.
88, yes. 88.
So after that, I did the whole angles around whatever.
You got the red one. Okay,
Yeah,
what did you get?
I can't remember what I got. But anyways, Y is ace.
Okay, let's just do the journey together. So I like where we're going. 360 minus 88. In my mind, I take away 60, I get to 300, and I've got to take away 28 more. So I get 272 for the red bit here.
Yeah, sir.
And now how do I get from my 272 to what you're claiming? What idea am I using?
You take the 272 Nessa, and then you half it.
You halve it. I agree with you.
Get the Y, sir.
You are winning. You are winning. Well done. 136.
Yeah, sir.
Answer is A. Now, we'll learn another theorem about that next week, but that was good. Thank you so much. Okay, everyone, I feel like, sure, we need some more practice, but we have mastered this theorem. And so before we have our break, I just want to introduce you to another amazing new theorem that we're adding to your journey, your circle geometry knowledge. So here is something else that is bananas the first time I saw it. And if you draw this in a circle, if you construct a circle and draw this angle, you'll be like, really? Why has no one told me this in my mathematical, world so far? So look at this rather strange behavior. Okay, that's 270. That doesn't quite make sense. But if you look, I'm moving this point. Who can describe to me what this theorem is saying? Who can tell me what this theorem is saying in your own words? Looks like it's dancing. Boom, bah, boom. Okay. Who thinks they know? Who wants to try and put this into words? Ayole, Temi, what do you think?
We have a hand from Buva or Mr.
Wow.
Yes.
Let's go to you.
Hello, sir.
Hey.
Yeah, so okay, as you see, like the more you move it, like it does not change like the degrees, it stays 90. So at that point, the point there, it's 90 degrees.
Okay. What is this over here? What is this line, this chord? Okay. Oh, this is interesting. Look at this. If I move this point, if I go back through the middle, it's 90. The moment I do this, it starts misbehaving. So maybe you can tell me what that means. Any idea? So
I think
what
we
it
lost
means,
him, Mr. Yes.
okay, no, that's fine. So if you go, the line that goes through the center of the circle, let's go to Sia Takoza, what do you think this theorem is telling us?
Hi, sir.
Hey. What do you think?
I think it moves because it's no longer a diameter. It's shifting down to the chord.
This is very important. So it's a diameter. The line that builds everything for this theorem must be a diameter. And what's the fancy word for building an angle? It's to subtend. So if the diameter, if it subtends an angle at the circumference, that angle will always be 90. However, if your diameter is, if your line is not a diameter, it won't be 90. So This is often called the angle in a semicircle. And the reason it's called the angle in a semicircle is a diameter cuts a circle into two semicircles. And so a new theorem that I want you to think about today is that if you've got a diameter in a circle and you make an angle at the circumference, or the fancy word is subtends an angle at the circumference, you get 90. So let's see how this idea can be used in a question. Here is your question. What is the size of angle P? What is the size of angle P? Now, there's a couple of ideas you need to think about. So I'll give you some time. Think about what shapes are on the board, what you know about, and just see what comes to you. And then you can let me know. Which answer do you think is correct? Is it A, B, C, or D? Oh, I like it. There's all sorts of variation. There's A's and B's and D's, which means there's C's. So there's some healthy debate going on here. Who would like to explain their choice to us? Who would like to stand up for their choice? Again, you get the respect just for being thing for the class. Faith, yes, let's go to you. What do you think?
So you see where the 90-degree angle is?
Yeah.
So we're gonna say yes.
Okay.
We're gonna say 180 minus 90.
Ah, I see where you're going. So you're not using that theorem, you're using something else. What else are you using to answer this question?
Minus the given angle 18.
Okay. Can I ask you where the 180 comes from? Where does the 180 come from?
Triangles angle always add up to 180.
Okay, that's important. You recognize this is a triangle. And so you knew something about a triangle. Okay, and what was your final answer?
72 degrees.
I agree with you, which would be option D.
T.
So it's
Yes.
not that 90 isn't a round, it is a round, but the question didn't ask about that angle, it asked about the angle P. And so there's also a interpretation. Well done, Faith. That was good. Okay, everyone, we have been working hard, and when we've worked as hard as this, we want to give our brains, we want to be thankful for our brains doing what they do. And the way we thank them is by having a brain break. So let us do that. Oh, what happened there? Can I ask you to turn on your cameras and to stand up with me as we go to this, pretty much the highlight of the lesson, really. I mean, this is why you're all here, I know. And let us shake off the tension for the day. So let's shake it out, shake those hands, pretend you're doing jazz art or whatever it is. And oh, that feels
Come on,
good.
guys, please turn your cameras on and see your lovely faces.
Yep. And then, oh, wait, let me go this. And
Don't be
then
shy.
you're going to do a slow rotation, like nice small rotation. And then as you get stronger, you can rotate to almost like you're getting to the diameter. So you're from one side to the other side of the circle. There we go. Oh, that feels good. Okay, then, since we're doing circles, we're going to do circles in our little brain thing. We're going to do small circles. The radius is small. And then as the radius gets bigger, the circle has no choice but to get bigger. There we go. Okay. Oh, that feels good. Pretend you're doing the butterfly. Oh. And then what should we do for our high intensity item? Should we do, okay, we do 5 jumping. Just 5 jumping jacks. Count them with me. 1, 2, 3, 4, 5. Oh, okay. Nice.
Yay. So proud of everyone who didn't do it sitting down.
Yep.
Nice one, guys.
And your brain will pay you back. This is not, this is, we know our brains, we weren't designed to sit. That's not how that's not how we're set up.
The brain juices are flowing now.
Yep. Okay, let us try. Now, the way this game works, for those who are new, is we try and make 24 using 4 numbers. The red one is slightly easier. The blue one is slightly harder. You have to use every number, and you're only allowed to use the operations plus, minus, times, and divide. So let's see what you can do. Nice. Okay, I see Annie has an answer in. See if you agree or you have a different one. I see that. Oh, there's a nice one. Another different one of doing it 2 times. It always amazes me how many different ways there are of doing this. So I see at least 3 correct answers so far. I see Annie's one was 6 times 3 plus, wait, 6 times 3. Oh, so Annie, you've used up too many 3s. So you only get 2 3s that you can use for this. So I think that is not quite correct at this stage. But if you go 6 times 3 plus 3 times 2, that gives you 18 plus 6, which is 24. That is awesome. So Rafiwa, I looked at your answer, and there's a couple of other good ones other ones that work. And there can sometimes be as many as 5 different ways of doing this. Okay, let's try and do the blue one as well. Anybody able to do the blue one? Oh, no problem. Who can get me to 24 using the blue cards here? Oh, flip. Somebody, you got it. You're quite right. Clearly, guys, sometimes the multitasking is a bit much for me. It's
Good eyes, Akile.
on the money. Old age, yeah? What you gonna do? Comes for us all. Okay. Okay, so I'm going to give you another 30 seconds or so, then we're going to go back to our thing. But what can we do? Actually, for the moment, I haven't got this one either. Oh, Louisa, let's go to you. Hey, Louisa, do you have an answer for us? Or was that maybe that hand, was that a mistake hand? Okay, I'll give you the blue one. My brain has suddenly had a flash of inspiration, but maybe Louisa saw this. Would you all agree that 8 times 3 is 24? Now, the problem is I've got to still use up the 3 and 2, but 3 minus 2 is 1, and 24 times 1 is just 24. So I kind of like used up the 3 and the 2 in a sneaky way by getting 1, and you can use 1 to do anything. And that was my sneaky way of doing it. Okay, everyone, our brain break is done. I hope you enjoyed that. Let's go back to our learning. Not that brain break isn't learning. I want us to try now. I saved this question. I just want to see if you can use your general knowledge of circles to help you figure out this one. So we've been doing a couple of theorems, but every now and again, we have to zoom out and think about the big picture. And so can you solve this using whatever knowledge you have? What is the size of the missing angle X? I think they meant to say X. Is it A, B, C, or D? Okay, I see a couple of B's and I see a couple of C's. I'll give you one little top, well, I'll ask you in the chat, what is special about these two lines? They feel strangely familiar from the beginning of lesson one. What's important about those two red lines? Can anybody help me out? Old age is striking again. My vocabulary is shrinking. So what's special about these things is I think these are both radiuses, which means that they're equal in length, which means that that angle over there will also be 40 degrees because it's an isosceles triangle. Okay, but now we want to find angle X, and we know that there's 90 there already, and there's 40 here. So then I go 180 minus 90 minus 40, and I get 50, which gives me C. So whenever you deal with circles, you often are going to have an isosceles triangle, because the moment you have two radii and a chord, you get an isosceles triangle. Give me a thumbs up if that made sense to you. Give me a thumbs down if you're like, oh, too many circles here. Because what I'm trying to do in this course is I'm trying to give you the main visual patterns that come up all the time. And this one comes up all the time because it's so natural to a circle. Okay, let's go back to that new theorem that we were learning about. Let's see what type of questions that can come with. Did that one. Let's do a couple of these. So I want to know, what is the size of the missing angle X in this one? So what is the size of the missing angle X? Ask yourself, what are the pieces of the puzzle that you have, the tools? What's special about this line? It feels like that's a diameter. And if that's the diameter, then the diameter subtends an angle of 90. And that's good news because all triangles add up to 180. So I go 180 minus 90 minus 50, and I get left with 40, which is B. So, no, from what I saw in the chat, you guys were like, piece of cake. So let me not hold you back. Let us, okay, that's going to be a bit easy. Let's look at something like this. All right, now I've changed things a little bit in this next question, so I'm going to choose some of them to keep track of. I want you to do for me question A, 1A and 1B. So just in your answers, you can say like question 1A and then give me an answer for A and B. And then for 1B, you need to find me A, B, and C. So see if you can do that now. Let me highlight the ones I want you to do. I want you to do that one. And I want you to do that one. Find me A, B, and C. Okay, so I see Annie, Sakile, Temi have all said that A is 90, and I agree. It kind of flows naturally from what we were doing. What is B going to be? Okay, so Cynthia, and I agree with you, Cynthia has said B is 35 degrees. So we've done with A. Now we're going to do B. Now, B is a little bit harder. So we have to think about what is the order in which we want to do it. What's the easiest one to do here? Oh, you know what? For B, there might be another theorem that I have to teach you still, a cyclic quad theorem. So we may not. So for B, I know that A is 90, right? So I know that A is 90. Oh, but I think I can work out C using this triangle, can't I? So if A is 90, so I know what this is. Now I would think go to C. We leave B for later. I think I'm just going to use the triangle. I'll go 180 minus 690 minus 62, and I should get 28. No, not, yeah, 28. It's not B, it's C, that's 28. Can someone help me by explaining to me how I get B? Yeah, Umta, what do you think? How am I going to get B? Hey.
So I'm just asking. I really don't know. But aren't like chords or arcs equal if they subtend equal angles at the circumference or circle center?
Okay, we're going to get to that theorem a little bit later, so I haven't touched on it yet. Equal chords do
But sir,
subtend.
isn't B equal to C? Like, aren't they the same?
Okay, I think they are, but what I was thinking is, surely, okay, follow my logic, see if you agree. Would you agree, Umta, that this is 90 degrees because it's an angle in a semicircle, or it's the chord, the diameter makes that angle at the circumference? Would you agree that that's
Yes,
90?
sir.
So what I was thinking for me is I should just go 180 minus 90
Minus 90, okay.
minus 32. So what do you get for that?
Wait, let me check.
Cool. Maybe you can tell me in the chat what you think B is. So at first, when I looked at this, I was a little bit like, how do I know how to find these? But I can just use triangles, and I can also use the angle in a semicircle, as it's called. Aha. So if I take 90 and I take away 32, I get 58. Now, how does that work? Okay. Everyone, there might be a bit of a problem with this quest. Wait, no, that's not going to be a problem. It does work out. Yeah. 58. As long as the 32 only goes over. Okay, what we need to debate, and I'll clear this up in future lessons, is whether the 32 relates to just that bit, which is what I'm assuming it does, or does the 32 refer to this whole thing? And depending on what you decide about that, that would play a role. Okay, but right now I'm interpreting it that the 32 there, if that is 32 and that's 90, then this has to be 58. Okay. All right. Lebo, can you put the link to the quiz in the chat? Everyone, you've done really well today. And I'll just take a moment to think over some of the things that we've spoken about over the last 2 lessons. So let me quickly go to a blank page. Let's overview. So this week, we spoke about the circle, and we spoke about what happens if you have 2 radii, and the radii make these isosceles triangles, which are quite helpful. We also spoke about if you have an arc that makes an angle at the center, it can also make an angle at the circumference. And then we also spoke at the end now that if you have a diameter, the diameter makes or subtends an angle of 90 degrees at the circumference. And over here, what we said was if this is x, this would be 2x. It's double the size. Okay, so there were a couple of other things that we did practice, but those for me stand out as the main ideas along with vocabulary that we reviewed. And so, yeah, and so I'm going to ask you now to take our quiz to just see kind of how things are going for you. And that just helps us gauge kind of if the lessons are going at the right pace, are you enjoying them and stuff like that. Okay, let's go to Cynthia. Cynthia, what is your question?
Yeah. Hi, sir.
Hey.
How are you?
Very good, Cynthia. How are you today?
I'm okay. I wanted to ask, in the previous question, how did you get the value of C?
I gave the value of C. Let's have a look. C of, yes, I did give the value of C.
How did you get it?
Okay, if you look at this, let me use blue. Look at this triangle that I'm going to trace out right now. And we know that all triangles add up to 180. So that we've got that in our back pocket. Now, this triangle happens to have as one of its sides the diameter. And when you know it's the diameter, the angle at the circumference is 90. Okay.
Yes.
Now, you also given that this angle down here is 62. And so the question is, using that information, how do I find what C is? Well, I go 180 minus 90, so 180 minus yellow minus green gives me the pink.
Oh, okay. Thank you, sir.
That makes sense. Pleasure. Thank you for your question. It was a good one. I think you helped a lot of students there.